Hello. In this video, we're going to start talking about non-real complex solutions. So once all rational and irrational zeros are discovered, there may still be imaginary zeros. Once again, the quadratic formula may be useful in finding the remaining zeros. Also note, imaginary zeros do not correspond to an x-intercept. So the instructions here are to find all zeros of the following polynomial function. We have f of x equals x cubed minus x squared minus 4x minus 6. Okay, so to do this, we could go ahead and try to factor, but that's not going to help. So let's go ahead and go to the calculator and find some zeros there. I'll see you there. Okay, so let's go ahead and type this in. X cubed minus x squared minus 4x minus 6. And then we graph it. Now notice that this only crosses at 3. Notice down here you've got a local maximum and there's also a local minimum here. Anytime you have local maximum and minimum on the same side without crossing the x-axis, you're going to have an imaginary zero of some sort. We do have a real zero at 3 here, and it's multiplicity of 1. So let's go ahead and go back to the notes and use this information. Okay, welcome back to the notes. So let's go ahead and prove that that 3 was a 0. So 3, upside down division, 1, negative 4, and 6. Bring down the 1, multiply, add, multiply, add, multiply, and add. Awesome. We just proved that the 3 was a 0. The next thing we want to do is go ahead and find the other zeros. Notice that this means that we have x squared plus 2x plus 2 all equal to 0. Now we could try to factor this, but nothing multiplies to 2 that also adds to 2. So we're going to have to use the quadratic formula, which means we need the discriminant. Here a is 1, b is 2, and c is 2. So it means that this is 2 squared minus 4 times 1 times 2. So it gives me 4 minus 8. And 4 minus 8 is negative 4. And notice that because this is negative, that's the reason we're going to get a non-real complex solution from this. Using the quadratic formula, negative b plus or minus the square root of the discriminant all over 2a. Well, negative b means negative 2, then plus or minus the square root of negative 4 over 2 times 1, which is 2. Notice we need to simplify the square root of negative 4, so that gives me negative 2, and then plus or minus. Notice square root of a negative gives me an I, and the square root of 4 gives me a 2. So the square root of negative 4 is 2i, all over 2. And because we have a non-real complex solution, you must break this up into 2 separate fractions. So this is going to become x equals negative 2 over 2 plus or minus 2i over 2. And then simplify. 2 over 2 is 1, so that makes that negative 1. Plus or minus 2 over 2 is 1, making that just I. Awesome. So we have 2 solutions here, and we have a 0 here. So 2 zeros here, 2 zeros, and a single 0 here. Maximum of 3 total. Fantastic. That means that the zeros of this function are the following. We have 3, and then negative 1 minus I, and negative 1 plus I. Now, if you're wondering which one should go first in numerical order, well, you should keep wondering that because it doesn't work. Unfortunately, once you get into non-real complex solutions, there's no such thing as one thing being larger than the other. It's kind of weird, I know, but the idea of numerical order kind of goes out the window at that point. So just write them in whatever order you want. Alrighty, well, I'm going to go ahead and end it here, and I will see you in the next video. Have fun.